So in this example, we're given a lot of 1,000 automobile pistons, and they're checked for consistency. They've determined that the pistons in the lot have an average, so a mean diameter of 4. So x bar is equal to 4. And then a standard deviation here of 0.02 inches. So S is 0.02. Lots are rejected if 150 or more pistons have diameter less than 3.94 or greater than 4.06. Will the lot be rejected if the distribution is mound-shaped? So we know this distribution is mound-shaped. So let's sketch our bell-shaped distribution. And in the middle we have our mean, which is at 4. And then we'll add 1, 2, 3 standard deviations, so 4.02, 4.04, and 4.06, and then subtract 1, 2, 3 standard deviations, so that would be 3.98, 3.96, and 3.94. And then we're asking what is the number of pistons that are less than 3.94 or greater than 4.06. Okay, so that is a distance here of 3 standard deviations. And if we look at our normal distribution curve, we know that from empirical rule, 99.7% of the data is within 3 standard deviations. And that means that on the outside here, past 3 standard deviations is going to be 0.3%. So 0.3% is 0.003. And so we're going to take that 0.003 and we are going to multiply it by the 1,000. Which is just going to move the decimal 3 places. So this tells us that there are 3 pistons that are in the range past 4.06 or below 3.96, if we know the data is mound-shaped. So we're certainly not going to reject here. So they're asking, will the lot be rejected? No, not rejected. Not even close. Now, what if we knew nothing about the distribution? Okay, so if it's not mound-shaped, then that's a different question. So if it's not mound-shaped, then we have to use Chebyshev's rule, and we're asking what is the amount that is beyond 3 standard deviations. So K is equal to 3. So that means that there is at least 1 minus 1 over 3 squared, which is 8/9 within 3 standard deviations. So that means that there is going to be, if at least 8/9 is within here, then that means that less than 1/9 on the outside. So less than 1/9 is beyond or past 3 standard deviations. So we take that 1/9, multiply it by 1,000. So let's see here. So 1,000 divide by 9, 111. So less than 111 pistons. So it's going to be less than 1/9 or less than 111 pistons. Still not over 150. So no, not rejected. And again, for the normal distribution, I'm using this diagram, 99.7 within, so that means 0.3 out here. And then for the Chebyshev, I'm using this guy. So 8/9 is within 3 standard deviations, so 1/9, less than 1/9 is left outside. So that's the thinking process there.